Okay, we are now in part 2 of the fall semester exam video review. This is starting on question 14 now. So the trig portion is asking you to find theta given that sine of theta is equal to the square root of 3 over 2, and it gives you this interval. So what this is really asking you is where is the sine value equal to root 3 over 2 in the unit circle. So this portion here, this just means that I'm looking in the unit circle. So I'm not going to put plus 2 pi n on my answer. So on your unit circle, go look for where the sine value, remember that the sine is the y value of the point, is equal to root 3 over 2. That happens at pi over 3 and 2 pi over 3. And those are the only two angles within the unit circle that have that value. So those are our only two solutions here. Okay. The number 15 is asking to find all values. So this solve for all values, this immediately tells me that I'm going to need to put plus 2 pi n after my answer. So that means I'm not just looking at the unit circle, I'm looking at many different values within the unit circle. Okay, so I need to solve this equation first to get sine of theta by itself. So I'm going to try to get all of my trig functions on one side and all of the plane numbers on the other side. So I'm going to move this sine theta, this one here, I'm going to move that to the other side. So I'm going to subtract sine theta from both sides. So these are gone, and I have negative root 3. Negative sine minus a sine gives me negative 2 sine theta. Then I want to get rid of the negative 2 in front of the sine theta. So I'm going to divide both sides by negative 2. Negative root 3 over negative 2. The two negative signs are going to cancel, and you're going to get positive root 3 over 2 is equal to sine theta. So this is pretty much the same thing as what you just solved on question 14 now, because this is asking you where is the sine value equal to root 3 over 2. So I'm going to take the two answers that I had for number 14, so the pi over 3 and the 2 pi over 3, and to those answers I'm going to put plus 2 pi n because it's asking me to solve for all values. So I'm not just looking in the unit circle, I can go around the unit circle as many times as I want. Now I can go outside of the numbers that are on there. So solve for all values, put plus 2 pi n, another great thing to put on your note card. Okay, number 16, I'm solving the following given the domain. And I'm looking for where cosine of theta is equal to 0. So this domain from 0 to 180, those 0 to 180, this is talking about quadrant 1 and 2, including all of the points. So any point that is either on the edges of 0 and 180, so they're touching 0 and 180, or they're in between, is a valid thing to be looking for. And it wants to know where is the cosine value equal to 0. So if you're looking at your unit circle, find where the cosine, remember that cosine is x, where the cosine value is equal to 0. That only happens in one place, and that's at pi over 2. So we have theta is equal to pi over 2. Okay, number 17, use the sum and difference formulas to find the exact value in fraction form of cosine of 255. So I like to use the sum formulas just because I think they're easier. What you're trying to do is take that 255 degrees and break it up into two numbers that are on the unit circle already. So two numbers that I can add together from the unit circle to get 255 are 120 and 135. So I'm going to call 120 my x, and I'm going to call 135 my y. Since I'm looking for the cosine and I'm adding these together, The formula that you're going to look for on your formula sheet is the cosine of x plus y. So cosine is coming from here, and I'm using x plus y because I'm doing a sum. I'm adding those two things together. So I'm just going to rewrite the formula. And then I'm going to substitute. So wherever I see an x, I'm going to replace it with 120. Wherever I see a y, I'm going to replace, excuse me, with 135. So I'm going to have cosine of 120, cosine of 135, minus sine of 120, times sine of 135. Okay? The way that you're going to find those numbers, you're not going to type this whole thing in your calculator. You're going to look at your unit circle. You're going to find what's the cosine of 120, what's the cosine of 135, and so on. So cosine of 120 is negative 1/2. Cosine of 135 is negative root 2 over 2. Sine of 120 is root 3 over 2. And sine of 135 is root 2 over 2. Then we're going to multiply these together to get our fraction form. So when you're multiplying these together, you're multiplying the tops together and the bottoms together. So I have two negative numbers being multiplied on the first set. That's going to turn into a positive. 1 times the square root of 2 is the square root of 2. On the bottom, 2 times 2 gives me 4. On the next set, root 3 times root 2 gives me root 6. And then 2 times 2 on the bottom gives me 4. So since these have the same denominator, I can combine them into one fraction with one single denominator of a 4, and this is my answer. Okay, next page, number 18. Use law of sines to find angle C. Since on your test, I'm not going to be there's no partial credit, it's just multiple choice. I'm going to run it through a Scantron. If you don't want to use law of sines and you want to use law of cosines, that's fine because I'm not going to be checking it. I'm just telling you I would use law of sines, but you can use the law of cosines if you want to. So I'm looking for angle C. So I'm looking for this angle here. So law of sines, the formula that I'm using, since I'm looking for angle C, I'm going to start off with the letter C, small c, which is side C, over sine of big C, is equal to something where I know the side and the angle. So let's label these real quick. So this is side A, side B, side C. So the letter for which I have the side and the angle is A. So when I'm writing my formula, I'm going to use A over sine of A. So I'm going to go through this formula and I'm going to replace the things that I know. So little c stands for side C. Side C is 72. I'm going to divide that by sine of angle C. I don't know what angle C is. That's what I'm looking for, so I'm going to leave that as a big C. Little a is side A, which is 69. And then sine of A, which is angle A, is 67. So once you get to this point, you're going to cross multiply. So I've got 72 times the sine of 67 equals 69 times sine of C. And then I want to get sine of C by itself. So I'm going to divide both sides by 69. Okay, you can type that fraction into your calculator. It's going to give you about this value. To get rid of the sine in front of the C, because I don't want to look for sine of C, I want angle C. I'm going to take the inverse sine, or arc sine, of this number, and that is what you're going to type in your calculator, and that should give you 73.85 degrees, and that is your answer for angle C. Okay. Number 19 wants us to find the area of this triangle. So when you're finding area, and in this case you were given 3 sides, you're going to use Heron's formula. So on your note card, maybe make a little note. If it asks for area and you're given 3 sides, you're using Heron's formula. So part of Heron's formula is finding S, which is 1/2 times A plus B plus C. This will be on your formula sheet. So do not write the formula itself, just write what situation to use it in. So let's label here. This is side A, side B, side C. So I've got 1/2. A is 15, B is 16, and C is 21. You can type that into your calculator as you see it there, and you're going to get 26. So I'm going to take, now I'm actually going to use Heron's formula for area. I'm just rewriting it. You're going to take your values and you're going to substitute those into the formula, and you can plug it in your calculator. Okay, so I've got S is 26. 26 minus 15. 26 minus 16. 26 minus 21. All of that's under the root. You can type that into your calculator and you're going to get this number. And that is your area measurement. Okay. Number 20, list all possible roots for the following polynomial. So this is asking you to use rational root theorem. You are going to be given the formula for this also. I'm looking for plus or minus P over Q. So the number that's in the very back here, this is P. And the number that's in the front, the 3, this is Q. So I'm going to take plus or minus 10 over 3. Now, you are not going to simplify this as a fraction. You're going to list out all of the potential factors for that number. So on the top of the fraction, I'm going to list out the factors of 10. So we've got 1, 2, 5, and 10. On the bottom, I'm going to list the factors of 3, which are 1 and 3. So the way I organize the breakdown of this is by making a table. So the numbers that are here are going to be the top. The numbers here are going to be the bottom of the fraction. So on the top, I've got 4, well really 8 potential roots. On the bottom, I've got 2 of them. I'm just going to fill in this chart. Okay, and then I'm going to divide. So the top, or the first row really, the number isn't going to change because you're dividing it by 1. So you're going to plus or minus 1, plus or minus 2 over 1, plus or minus 5 over 1, plus or minus 10 over 1. On the second row, now you're going to have plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 5 over 3, and plus or minus 10 over 3. So every single number that's in these boxes are your answers. There are 8 boxes total, and they all have a positive and a negative. So I have 16 potential roots here. So your answer choice, when you're looking at your test, you're going to pick the one that includes all of those choices that are in that box. Okay, number 21, we are writing the expanded form of this polynomial. So that just means multiply everything that you see in parentheses together. I'm going to pick 2 sets of parentheses first and multiply those together first. So I'm going to multiply x minus 2 and x minus 3 together. Then I'm going to combine these 2 diagonals. So I've got x squared minus 5x plus 6. Now that I've got this answer, whoops, I didn't mean to draw a line through that. I meant to highlight it. Now that I've got this answer, I'm going to multiply that with the x plus 6 that's there. So I've got x squared, negative 5x, positive 6, and then I'm multiplying it with the x plus 6. You're going to combine whatever you can. So I can combine a negative 5x squared and a 6x squared. And I can also combine a negative 30x and a 6x. That is going to give me x cubed. Negative 5x squared plus 6x squared is a positive x squared. Negative 30x plus 6 is negative 24x. And then the plus 36. So this would be my expanded form of that polynomial. Okay, last page. So this 22 is kind of a vocab question. A blank is a point that is lower than all other points in a small local interval. So is lower than all other points within a local interval. There might be other lower parts of the graph. So it's saying the area that I'm looking at, it's the lowest point. But if I'm looking at the graph as a whole, it may not necessarily be the lowest point that is on the graph. So it goes in this blank is a local min. If it were to say this is the lowest overall point on the graph, there are no other points that are lower than that, that would be an absolute min. Okay, number 23, this is a very calculator-based question. So on your calculator, you're going to graph this entire thing here without that domain restriction. So I'm going to say graph in calc. And then you are going to, after you graph it, you're going to click menu. You're going to go to trace. Then you're going to go to graph trace. And you are going to use your arrow keys to go left and right until you see the word 0. 0 is the same thing as an x-intercept. Your calculator just calls it 0. So once those two words appear, those are the 2 points that you're looking for. So when you graph this and you do the graph trace and you're clicking between the zeros, you're going to get 3 zeros total. You're going to get 0, 0, 1.340, and 6.410. Here's where the domain restriction comes into play. So I'm looking at this negative 7 and 6 part. It says that your x value must be between negative 7 and 6. The very last zero that I listed, the 6.41, that number is larger than 6. The x value is larger than 6. So I do not count that one as a 0 because it's not in the interval that was given. So the only two things that are the only two zeros or x-intercepts that I have are those two that I just boxed out in red. Okay, last question. This is actually going to be on your test. It's just a fun bonus question. I went to college at the University of Texas at Dallas. Okay, so just a fun question. You can't get it wrong. So those are all of the things that are fair game for your final exam. Please refer to the final exam schedule to see when your test is based on whatever class period you're in. If you have any questions prior to the test, please let me know. Remember, on your test, I will be giving you a formula sheet. I'll be giving you a copy of the unit circle. And then you can use a 3x5 index card, written whatever you want on it, front and back, but it has to be handwritten. You can use that on your test, okay? So if you have any questions, please let me know. Happy studies.